Minutes ago, scientists revealed the hidden signs behind the recent Philippines earthquakes. And this could be the first alarm about the start of the next megaquake. Tiny shakes are turning into a steady march of tremors, moving like a slow, invisible line under the islands. Streets that were calm an hour ago now hum with aftershocks. Scientists rushed out sensors, and every instrument is picking up the same odd pattern. Small quakes linking up, deep rumbles tapping a spot long thought quiet. This is not the usual one-off jolt. It's a building story. Pressure shifting, faults talking to each other, and a hidden trigger that might turn a normal quake into something far worse. Emergency crews are on edge. Coastal towns are watching the sea like it could flip in minutes. We're showing you the raw signs, the one tiny clue most experts missed, and what it could mean for millions. Is the Philippines on the brink of a chain reaction no one can stop? Beneath the Philippines, a relentless battle plays out every hour of every day. The archipelago sits at the crossroads of four massive tectonic plates: the Philippine Sea Plate, the Eurasian Plate, the Sunda Plate, and the Pacific Plate. Each of these plates moves in its own direction, dragging and shoving the ground from thousands of kilometers away. The Philippine Sea Plate pushes westward at around 80 to 100 millimeters per year, colliding straight into the eastern edge of the islands. On the opposite side, the Eurasian Plate grinds eastward, slowly diving underneath Luzon and the western coastline. To the south, the Sunda Plate presses northward, squeezing Mindanao and the Sulu archipelago. Meanwhile, the Pacific Plate slides northwest, adding another layer of tension to the mix. This isn't a gentle meeting. The plates don't simply glide past each other. Instead, they crumple, buckle, and jam together, building up pressure along every edge. The Philippines is caught in the middle of this geologic crossfire, squeezed from all sides. The pressure doesn't just vanish. It gets trapped along cracks deep underground, faults and trenches that zigzag across the country. Every year, the plates add more strain, millimeter by millimeter. The ground flexes, warps, and sometimes snaps. Most of this movement happens out of sight, far beneath the surface. But the signs are everywhere. Ridges rising in Bicol, valleys sinking in Mindanao, and islands shifting a few centimeters each year. GPS stations across Luzon and Mindanao record these tiny movements, confirming what scientists have long suspected. This is not a quiet place. The entire country is under constant compression, with the plates grinding together in a slow-motion collision that never stops. This endless pressure is the root cause of the Philippines' constant shaking. It's why the country experiences more than 17,000 earthquakes a year, ranging from tiny tremors to catastrophic jolts. The energy builds up quietly, sometimes for decades, until it finally breaks free along a fault or trench. The result can be anything from a gentle rumble to a disaster that changes the landscape forever. The collision of these four plates doesn't just explain why the ground shakes so often. It sets the stage for what happens next. The stress doesn't spread out evenly. Instead, it concentrates along certain lines, the deep ocean trenches and the massive inland faults that cut across the islands. These are the places where the pressure is most likely to be released, sometimes with devastating force. Along the western edge of Luzon, the Manila Trench carves a deep scar into the sea floor, a boundary that holds back decades, maybe centuries, of silent strain. Scientists have mapped this trench into 3 distinct segments, each with its own potential to unleash disaster. The southern portion, stretching from Mindoro up past 14 degrees north, is capable of generating earthquakes in the magnitude 8.0 to 8.5 range. The central segment, running northward, holds enough locked energy to produce a quake as large as magnitude 9.0. The northernmost stretch, though less understood due to gaps in data, could, in the worst case, rupture at up to magnitude 9.2 if the entire fault gives way at once. This isn't just a matter of numbers. Hydrodynamic modeling shows that if the central or northern segments rupture, the The resulting tsunami would not crawl toward the coast, it would race. For western Luzon and Metro Manila, the first waves could arrive in as little as 20 to 40 minutes after the shaking starts. In some scenarios, peak waves reach 5 to 10 meters high, especially where bays and river mouths funnel the water inland. In a full trench rupture, the sea could swallow entire neighborhoods before emergency warnings even finish broadcasting. Tsunami simulations reveal that the geometry of Manila Bay and other estuaries would amplify these waves, trapping water and prolonging flooding. In these areas, the difference between life and death could come down to just a handful of minutes. The models are stark. A single segment rupture might devastate a coastal town, but a multi-segment event could send walls of water across hundreds of kilometers, from Palawan to southern Taiwan. Harbor cities, with their dense populations and critical infrastructure, stand at the front line. The historical record offers little comfort. The Manila Trench has not unleashed a megaquake in modern times, but the absence of recent disasters only adds to the uncertainty. GPS stations on land show that the plates have barely moved to release strain since the 1960s. With each passing year, more energy is trapped beneath the sea floor. Scientists warn that the lack of recent rupture does not mean safety. Instead, it means the system is primed, the spring wound tight. When the shaking finally comes, there will be no long warning. The clock will start the moment the fault breaks. For millions living along the West Coast, every minute will matter. The threat is not just the ground splitting open, but the sea itself turning violent, an unstoppable surge that could arrive before the dust from the earthquake even settles. Night fell over Cebu with no warning. At 9:59 p.m. on September 30th, 2025, the ground convulsed beneath the city. Concrete buckled. Apartment blocks shuddered and split. Within seconds, people poured into the streets, barefoot, clutching children, searching for loved ones in the dark. Sirens wailed as rescue teams scrambled through dust and debris. The magnitude 6.9 earthquake was the most powerful ever recorded in the province. 72 people lost their lives that night, and in the chaos that followed, hundreds more were pulled from the rubble with broken bones and shattered spirits. Entire neighborhoods vanished under collapsed roofs and landslides. Schools, hospitals, and churches, some standing for generations, crumbled in minutes. Power vanished for over 800,000 residents. In the days that followed, more than 20,000 people were forced from their homes, sleeping in makeshift shelters or crowded gymnasiums, waiting for aftershocks to stop. But the shaking didn't end. By dawn, over 350 aftershocks rattled the city. By the end of the week, the count had climbed into the thousands. Each tremor sent a fresh wave of panic through the camps. Cebu's devastation was only one chapter in a much larger story. Across the Philippines, the earth has not been quiet. In 2025 alone, the country recorded over 17,697 earthquakes, an average of nearly 50 a day. 6 of these reached magnitude 6 or higher. 1, off Davao, registered at 7.4, sending ripples of fear through Mindanao. The pattern is unmistakable. The ground is not just restless, it's agitated. Each new quake brings more uncertainty, more families left searching for safety, more questions about what comes next. The numbers are stark, but behind every statistic is a life uprooted. In Cebu, parents dig through rubble for school books and family photos. In Leyte and Bohol, aftershocks keep children awake at night, terrified that the next one will be bigger. The surge in seismic activity is not just a scientific puzzle, it's a daily threat to millions. For those watching from safer ground, this is the moment to act. Every Filipino has a stake in what happens next. Subscribe now for the latest updates, expert warnings, and survival tips. The signs are here. The ground is sending a message. The question is, will we listen before the next disaster strikes? On the southern edge of the Philippines, Mindanao lives with memories that never quite fade. In October 2025, the earth shook off Davao's coast, with a magnitude 7.4, strong enough to rattle buildings from Tagum to General Santos, strong enough to send families running into the night. The tremors didn't just crack concrete and shatter windows. They stirred up something deeper, a fear passed down since the deadliest night in Mindanao's history. Nearly 50 years earlier, on August 17, 1976, the Cotabato Trench ruptured beneath the Moro Gulf. The shaking, measured at magnitude 7.9, was only the beginning. Minutes later, the sea itself came roaring ashore. Tsunami waves as high as 9 meters crashed onto the coastlines of Sultan Kudarat, Cotabato, and Zamboanga del Sur. Entire villages vanished in the darkness. By sunrise, more than 4,700 people were dead, nearly 100,000 were homeless, and the coastline had been rewritten. The 1976 tsunami remains the deadliest in Philippine history, a warning carved into the collective memory of Mindanao's coastal towns. For the people of Mindanao, these aren't just stories. They are part of daily life. In Labac, Calamansig, and Pagadian, families teach their children to listen for the rumble beneath their feet and to watch the sea for any sign it might pull away. Every strong quake triggers a rush to higher ground, no matter the hour. The trauma of 1976 is never far away, shaping how communities react to each new tremor. But Mindanao isn't waiting for help from distant capitals. In Davao and nearby provinces, volunteers have taken up the work of monitoring the ground themselves. Using low-cost sensors built from spare electronics and open-source software, local groups have set up their own seismic networks. These grassroots projects feed real-time data to PHIVOLCS and help spot unusual patterns, clusters of small quakes, sudden bursts of micro-tremors, or deep rumbles that official stations might miss. When the October 2025 quake struck, these community sensors picked up the first signals before the main shock even peaked. Within minutes, text alerts reached barangay leaders, giving precious seconds for evacuation in vulnerable areas. This kind of citizen science is more than just a backup system. It's a way for people to reclaim some control over a threat that feels overwhelming. In Mindanao, where every generation carries stories of disaster, these efforts offer a measure of hope. They show that while the ground may be unpredictable, the response doesn't have to be. The lessons of the past, paired with new technology and local initiative, are helping communities stay alert, connected, and ready for whatever the Earth decides to do next. A new kind of map is changing how scientists see the dangers beneath the Philippines. It's called a Coulomb stress map, a tool that doesn't just show where earthquakes have happened, but where the next one might be loading in silence. After every significant quake, analysts at PHIVOLCS and partner agencies feed fresh seismic data into these models. What they're looking for is a threshold, a jump in stress of just 0.1 bar or more along a fault segment. That's the tipping point that can turn a locked fault into a ticking bomb. The latest maps reveal something unsettling. Several segments have crossed that line, including the Infanta segment in Luzon, the Mati segment in southeastern Mindanao, the San Francisco segment in the south, and the southern Leyte crossings. These are not minor cracks. They are long stretches of fault that haven't seen a major rupture in decades. Each new earthquake in the region has added another layer of stress, shifting the balance further. According to Dr. Antonia Bornas, PHIVOLCS lead hazard analyst, we're seeing stress levels on some segments that have not been this high since the 1950s. The pattern isn't random. The 2025 Davao quake, for example, didn't just relieve pressure where it struck. It transferred stress to nearby segments, especially around Mati and San Francisco. The same thing happened after the Cebu event, pushing energy into southern Leyte. These maps are not predictions, but they are warnings. When a segment's stress rises above the 0.1 bar threshold, the odds of a significant earthquake go up sharply. For the first time, Analysts are seeing a chain of high-stress segments forming a potential pathway across the archipelago, one that, if triggered, could link up in a way the country has never seen before. Metro Manila stands at the crossroads of risk and responsibility. The West Valley Fault cuts beneath the capital's most crowded neighborhoods, traced by PHIVOLCS as capable of unleashing a magnitude 7.2 earthquake. Millions live and work within its impact zone, surrounded by towers, hospitals, and schools, many of which were never designed for the kind of shaking now expected. Official audits tell a troubling story. In 2015, a government survey found that 1 in 3 public schools and government buildings in Metro Manila were structurally deficient or outright non-compliant with modern standards. Hospitals have fared no better. A 2018 review flagged 38 out of 70 Metro Manila hospitals for urgent retrofitting, with some audit backlogs stretching for years. Even among high-rises, the full picture remains hidden. By 2024, Senate hearings revealed that up to 40% of older towers had not undergone a full structural audit since the last major code changes. These numbers aren't just statistics, they are warnings. In a city where a single fault line could bring down hundreds of buildings in seconds, every unchecked structure is a risk multiplied. The call to action is clear. PHIVOLCS and disaster agencies urge everyone: know your building's audit status. Demand transparency from property managers. Push local officials for published retrofitting records. Inside every home and office, drill the basics. Drop, cover, and hold on when the shaking starts. Map out your evacuation route in advance. Stock emergency kits with water, food, and first aid. For those in charge of schools, hospitals, or residential towers, schedule regular earthquake drills and review structural reports every year. The time to act is now, not after the shaking begins. In Metro Manila, survival depends on preparation and on refusing to accept silence or delay from those responsible for public safety. This year alone, the Philippines has recorded over 17,000 earthquakes, with deadly shocks striking Cebu and Mindanao just weeks apart. Historical records, from the 1976 Moro Gulf tsunami to today's PHIVOLCS and USGS stress maps, confirm that the collision of the Philippine Sea, Eurasian, Sunda, and Pacific plates continues to drive the country's seismic risk. Scientists have identified rising stress along key fault segments, such as Infanta, Mati, and the West Valley Fault, yet the exact timing and location of the next megaquake remain unknown. While modern sensors and community efforts have improved early detection, archival gaps and incomplete paleo-tsunami data still limit long-term forecasting. The evidence is clear. Major earthquakes in the Philippines are not isolated events, but part of an ongoing pattern shaped by powerful geological forces. As official audits warn of urban vulnerabilities, the need for preparedness is more urgent than ever. What lies beneath the islands is still unfolding, and every new tremor is a reminder to stay ready.